How's it going? It's video 11, and we're going to talk about 7.2 today. And I noticed right away that I forgot to change it to 7.2. But we're talking about congruence and transformation still. So we're taking chapter 6 and still merging it with chapter 7. And we're going to talk through a lot of congruencies and what can we say about figures that are congruent to each other. I wanted to take this lesson one step deeper than the book does because there are some things I want you to know about proving congruence with figures. There are these 5 what we would call maybe theorems or definitions or proofs that talk about triangles and how we know they would be congruent if they didn't flat out tell us. You're lucky in this 7.2 section, they tell us that every one of these is congruent, and so we just have to look at them and tell which ones are or not. So I use some of the problems that we are going to do to talk about what some of these are, but there is this SSS theorem that just means if you have 3 sides of a triangle that are congruent, then of course the whole triangle, they're congruent. Side angle side is one SAS, to where if you have a side, then an angle, then another side in a row, then that triangle must be congruent. If you have an angle, then a side, then an angle again, that triangle would be congruent. If you had an angle, then a side, they would be congruent. And the last one is if it's a right triangle, the hypotenuse, or the side across from the right angle, and then the next leg over, they would be a right triangle, and it would prove to be congruent in that aspect. Okay, but I'm going to do the whole reteach page, and then just 2 and 6 on the skills practice, and number 3 on the homework page. And then what I'm going to do is make up a homework assignment on your Google Classroom for some of the rest of the problems so that you can do some of those. My last video I wasn't too terribly happy with because my arm was in the way a lot, so we're going to try to take care of some of that with me using a baseball bat today just for fun. And I also called a trapezoid a parallelogram or something like that, so I apologize for that too. So we're going to move past those 2 mistakes because we all do that. I must have been on quarantine brain, and we're going to try to get this 7.2 taken care of. Now, to demonstrate SSS, side, 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 I drew number 1 where black is where you have a side, and a side, all those congruent. You're learning new things this chapter that I think they should have kind of gone a little bit slower on, and that a 1 notch and a 1 notch are used for sides that are congruent, and 2 notches, 2 notches, 3 notches, 3 notches, those all note that sides are congruent. Okay, the angle stuff, this particular one has all of the angles in red. 1 arc is congruent to the other 1 arc. The 2 arcs are congruent to the other 2 arcs. And the 3 arcs are congruent to the other three arcs. Some of that will make sense pretty easily, but some maybe not so much. Another thing when you're in geometry you have to watch out for is if I say triangle RST, to say it's congruent to this triangle, I have to have it in the same order of what is congruent. Meaning if I have angle R, which is this guy with 1 arc, the first one I have to have over here is the angle with 1 arc on this guy. Angle S has 3 arcs, so I have to next say the E. And angle F is corresponding to T. T has 2 arcs, and F has 2 arcs also. But for the side, 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 if I can say that 3 sides are congruent in a triangle, then that means that those triangles are congruent. For side angle side, if I notice that in black I had a side with 1 notch, then in between those an angle that is the same because they both have 2 notches, and then another side with 2 notches in a row, that is side angle side, and that would be enough to know that those 2 triangles are congruent. Angle side angle, I did on this guy. Angle with 2 notches, a side, and then an angle with 1 notch, angle with 2 notches, a side, and an angle with 1 arc, I should say. That proves that those triangles are congruent even without them saying the rest of these angles and so on and so forth. Okay, I will go over possibly one that's angle side, and definitely one that's hypotenuse leg, hopefully later today in this video. This video might end up being kind of lengthy, so I encourage you to have this one be another one where you stop it, catch up to me, do the work on each worksheet maybe at a time. Like when I finish these 4, stop it before I go on to skills practice and homework. That way I won't be going too far, too fast for you. But now let's go back to what's on your reteach page. Okay, your reteach page has these two triangles written next to each other, pending a tiny bit of maybe human error that happened when I drew them. Now, if these two triangles are congruent, they've already noted all of that stuff, not only in black but in red also. They told you all that stuff. Okay, and all they're asking you to do on this particular assignment, and this number one will be kind of crammed because of the space of me drawing all four. But once I do number one, I'm going to erase it so that I can do number two without too much messiness. And then so on and so forth, there'll be a lot more room. But obviously, since I told you about the notches and the arcs and how many, when you are told that these are congruent, okay, and you are just asked to make some congruency statements, by the way, if I didn't say so already, this is the symbol that means congruent. You're going to use this little equal sign with a squiggly above it. I can say, since R has one notch, I can say angle R, that's how you would say angle R, is congruent to what angle? What other one has a one notch or one arc to it? It would be angle D, right? I could say angle S is also congruent to, what do you think? If this is S with three arcs, it would be angle E with three arcs. Okay, if I wanted to say, I said R, I said S, I can say angle T. That's congruent to, well, angle T has two arcs, so it would be congruent to angle F. I also know that there are three sides that are the same. And when you name sides, you name 2 points, and you put a line over them, meaning it's a line segment. And just like I said with the letters having to be in the same order, if I name a line with the 2 points in one order, I have to concentrate on that in the second one. So in other words, if I say R, T, this line right here, I started with the R to T, if I wanted to say it that way, that line would have to be congruent to the point where there's one arc, D, to the point where there's two arcs, F, and so the RT is DF, okay? And if I did TS, that would be congruent to 2 arcs to 3 arcs. 2 arcs is F, E, right? Like I said, this is going to be really small and crammed until I do number one, and then I can make it a tiny bit bigger. Then the last one that I haven't done is SR. I don't think I've done, no. And that's congruent to, if I did SR, 3 arcs to 1 arc, I'm doing ED. I can say all 6 of those things just by knowing that these two shapes are congruent, and especially when they're all marked for us. Okay, moving back and pointing, I know 6 things that have to be congruent with those dealios. So that much is true. If you are asked like you are number one on reteach, it just says write congruent statements comparing the corresponding parts in the congruent figures. Corresponding parts means the same part here has to be congruent to the similar or congruent part on the other triangle. That's what congruency means, and that's what corresponding means. Okay, so catch up on that one while I erase number one so that I have more room for writing some of these in. Let's say I look at number 2 here, and remember I use this as a side angle side demonstration, but then in red I put the rest of them in there that are given to you. I'm told that they're congruent, so right away I should know that if I have these two shapes, they're congruent. Told that they're congruent. If you didn't know, first of all, you might be able to say, well, I just rotated that over a little bit, okay, 90 degrees or so, and I still see what's congruent and what's not congruent. If I started with angle U, I know that angle U should be congruent. I'm going to switch out markers because this one's starting to die, I think. Angle U, if this is angle U and it has one arc, then it must be the same as angle J that also has one arc. Okay? If if I take angle, say P, that must be congruent to angle P has 2 arcs. S has 2 arcs. Those must be congruent. Okay, if I say angle T, that must be congruent to angle R. Okay, that's straightforward. If I want to say side like UP, okay, UP is congruent to the same one that would be JS. And remember, I can't say SJ because that's the opposite direction. I want to make sure everything's staying in the same direction. Okay, if I say UT, UT goes 1 arc to 3 arcs. My 1 arc to 3 arcs is this one here, JR. Okay, and the only other one I haven't done is PT. P is here, T is here, so SR would be the one that's congruent to that guy. I can say all 6 of those statements based on the fact that those are congruent triangles. Okay, I'm going to take a second, let you catch up, stop the video if necessary because I'm going to start erasing, and so unless you have all those down, you might have to stop your video. So that now I have even more room to write some of these. Number 3 down here, okay, I wrote in black this angle, this side, and this angle to prove that angle, side, angle would be one way you could tell they're congruent. Okay, but I put in all the rest of the stuff so that you know that triangle ABC is congruent to triangle GFE. Okay, so knowing that, this one's a little bit more straightforward because you can see they just moved it down, they just translated it down, so you can see all the corresponding things. If I look at angle A, that must be congruent to angle G. Okay, and A and G are in the same points when I say these triangles too. Note that. Angle B would be congruent to, if I use these, I should know it should be F, correct? And so when I look here, I also know that that's congruent to angle F. And angle C is congruent to, we should know it's angle E. And again, angle C and angle E are the same spots. If I do side AB, if I do it right, I should know that AB should be the same as GF, right? And we should know AB is the same thing as side GF by also looking at the picture and noticing that they each have 1 notch on them. Okay, if I do BC, it should be the same thing as FE, right? If I look at BC, it has 2 notches on it. If I look at FE, it also has 2 notches on it. So I know that FE is also one of the things I can note. And the only other one I haven't said is AC. Well, that means that if this is A and C, I should have G and E, right? Well, if I look at AC and GE, they are the same corresponding sides. Okay, hopefully I'm standing out of the way enough for you to see those, catch up. I don't even need to erase those because I have plenty of room to talk about the quadrilateral one. There is no difference when we start doing this quadrilateral one. I'm going to rewrite this up here where I have quadrilateral and I have PHGO. PHGO is congruent to quadrilateral. I have to put these in the same order. So it would have been IS and R. P by the 2 arcs. Which one's by the 2 arcs is I. H should be by S. And remember, this is rotated, so it's not H and I, it's H and S that way, and so on and so forth. The nice thing about that is, if I didn't even have these shapes drawn, you could say all the congruent parts to these 2 shapes. Because if I said angle P, you should know without even looking at the shapes that P is going to be congruent to angle I. And if you look here, P has 2 arcs, I has 2 arcs, checks out. I should know that angle H should be congruent to angle HS. Okay, and if I check, here's H, it has 3 arcs. S also has 3 arcs. If I do angle G, that should be congruent to angle N, right? And if I look at angle N, 4 arcs, G, 4 arcs, perfect. And if I look at angle O, that has to be congruent to angle O has 1 arc, R has 1 arc, O is at the end, R is also at the end. So angle O is congruent to angle R. Okay, even if I didn't have those pictures drawn down here, okay, then I could still say all of this based on the fact that in geometry you should be used to writing them in the right order at the right corresponding parts, and so you wouldn't even necessarily have to look at the drawing, you would know those corresponding parts. So if I go into segments now and I say segment PH is congruent to, well, if I took PH here, shouldn't it be the same thing as IS here? Well, if I look at PH, it's got 3 notches on it, right? If I go to IS, IS also has 3 notches on it. Okay, good, perfect. Okay, if I go to, say, HG. Okay, HG is this guy with 2 notches. Okay, it should be congruent to SN. Well, if I look at here, HG, that's also SN over here. And if we look at our drawing, HG, 2 notches, SN, 2 notches. We've done good so far. If I go to GO, line segment, line over it, congruent symbol, GO should be the same thing as NR. Well, GO has 4 notches. NR also has 4 notches. Okay, in the order of the 4 arcs to 1 arc. 4 arcs to 1 arc. I've gone the right direction and everything. Okay, the one that might be hard to see is line PO. That'll be the last one in a 4-sided figure. That's this line right here. Okay, maybe guess real quick on which one I'm going to put. But if PO is congruent to a segment over here, it must be congruent to IR. I hope you can see. IR, 1 notch, PO 1 notch. I has 2, P has 2, O has 1, R has 1. All those things that you can kind of see to make sure you're doing these in the correct order. Okay, take a look at that while I do some erasing. Pause it if you need to so it's all still there while you'll catch up. While I do some quick erasing on this. I'm getting rid of all this and going on to the skills practice number 2. Maybe if you didn't pause it, you fast forward through me erasing, but skills practice number 2. Okay, I'm going to draw these a tiny bit faster this time. Okay, but if you have a triangle, one of them has its flat shape up here, kind of, and it's W, U, S, 3 notches here, 1 notch here, 2 notches here, 1 arc here, 2 arcs here, and I'm assuming, yep, 3 arcs there. And we have another triangle that's supposed to be similar in shape, looks like this. What it is they've rotated it, okay, and then slid it over. So I have Y here at the same angle where there's 2 arcs. So you should know that 2 arcs here is U. That's where we're going to be the same as. We've got T over here, and angle T has 3 arcs. So that's going to be the same as S. And angle X has 1 arc, and then you'll see there's 1 notch here, 2 notches there, and 3 notches here. Just knowing that, I can say that angle S is congruent to angle S, 3 arcs. Which one has 3 arcs over there? Okay, angle T. Okay, angle, say U maybe. If U has 2 arcs, which one has 2 arcs over there? The Y does. Okay, and then finally, W, what would it be congruent to? If it has 1 arc, it would be congruent to angle X. Okay, if I'm doing lines, okay, the one with 1 arc, excuse me, 1 notch, would be WU. And if I went from WU to say it's congruent to a line segment over here, I would have to go from X to Y. If I wanted to go from, say, WS, that would have to be congruent to W was 1 notch, S was 3. X is 1 notch, T is 3. So I go XT. And if I wanted to say US, okay, US is from 2 notches to 3 notches. That would be this segment, YT. A good idea some of these times would be to stop yourself on the video before I write that and see if you can guess before I write it to kind of see if your answer is correct. Okay, the only one I want to do on the skills practice is number 6. Okay, quick erasing, stop the video, fast forward the video, whatever you need to do to get to where I'm going to be when I'm doing my, this time, these are 2 trapezoids. I'm going to say it right this time. The 2 trapezoids, one is like this, and the other one is just like it, but reflected down. Big key. M-P-O-N. If I label this M-P-O-N like this, okay, one way I can do this is I can say it's reflected and say P and Y are the same, but they don't talk about it like that. They talk about it as if they rotated it. Okay, so I want to do it the way they are rotating it, because if you notice, P has 3 arcs. If I just reflected it, that would mean this has 3 arcs, but it's not. They put the 3 arcs way over here. So that's how you know that, tell you the truth, 1, 2, they gave it 4 arcs, that's what it is. Okay, so that makes sense. I thought that was 3. Yep, 4 arcs. Okay, that's how we know that they rotated it instead of flipped it. Okay, 3 notches, 3 notches. Okay, we took care of P. P was congruent to X. Okay, this is 3 here for W, which is the same thing as what O should be. 3 notches here, 3 arcs there. Okay, then we had, if I just continue the top one, this was 2 arcs, this was 1 arc, this was 1 notch, this was 3 notches, this was 4, this was 3, okay, and the bottom one was 2. This should be 2, okay, this one should be 1, this one should be 3, and the bottom one, I need my glasses on or something, it was the one it was 4. Okay, so here's what we have. This is W, X, and Y, and Z. These are the 2 parallelograms. Something you might want to notice right away is if I were to name this congruent statement, okay, I would have to say that quadrilateral, if I do M, then I do, let's do it this way because that's alphabetical order, M, N, O, P. And I wanted to say it's congruent to something, I would have to say congruent to what? Quadrilateral. M is the one where there's 1 arc. Okay? And if I had been smart enough to finish all of my arcs, I look at this, and the one with 1 arc is angle Y, right? So I have to start with Y. Okay? I'm assuming this one has 2. Z must have 2. Yes. Okay? I have angle N next, has 2, so Z has 2, so I would have to say Z next. Okay, if I have O next, that has 3 arcs, the one that has 3 arcs is W, so I would have to say W. And if I have P last, the only one that's left, I have W, I have Y, I have Z, W, I have X. I don't have, I get confused sometimes, 4 and 4, which is X. Good. Okay, that is the same order as that. Okay, if I erase that picture, you could say all the congruent statements just based on what these guys say. Okay, let's go angles first. I could say angle M is congruent to angle Y, right? Because angle M has 1, angle Y has 1. I could say angle N is congruent to angle Z, right? Because they're in the corresponding parts. Angle Z has 2 arcs. Angle N, guess what it has? 2 arcs. Okay, angle O, it's got to be congruent to angle W. Well, O has 3 arcs. W has 3 arcs. Okay, and then angle P has to be congruent to angle X. Okay, P has 4 arcs, X has 4 arcs, proves it right. Okay, if I go line segments, say I say MN first, it should be the same as YZ, right? Well, MN, 1 notch, YZ, 1 notch. Okay, if I do, say NO, well, NO would have to be the same thing as ZW. Okay, well, NO, 2 notches. Okay, ZW, 2 notches. What about OP? Congruent to, if this is OP, it would have to be congruent to WX. Okay, well, OP is this one with 3 notches. WX is this one with 3 notches. Okay, and then the one that may or may not be hard to see by just these, but you should be able to see it on the drawing. If I did MP, MP is this guy with 4 notches. It's going to be congruent to this, but make sure we have it in the same order. If I did MP, it'd have to be YX. Okay, I know all of those statements based on what they gave you and told us that it is congruent. Okay, that is number 6 on your skills practice. That means I just am going to do number 3 on your homework, and that's one of the ones that I wanted to say, the hypotenuse leg theorem I wanted to point out, because since it's on a grid, we can tell that it actually is a right angle that we can say is a right triangle, so that we can use that hypotenuse leg look. Okay, they give you a small grid. I obviously have a much larger grid. If I drew my triangles the same size as they did, it's going to be pretty small, but I want to do it only because of similarity coming up in the next section. So their MN only has 3 blocks. Okay, if I go 1, 2, 3, their MN is represented like that. Okay, N to L is only 2 over. And then we have that triangle. If I called that triangle, I'll say LMN, a little bit different than what I said it when I drew it. I wanted to go alphabetical order again. That's going to be congruent to, if we had a triangle over here that's then 2 this way, and then it goes 3 that way, and then we connect, and our letters are Z here, X here, and Y here. This is going to be congruent to a triangle. Well, L is same thing as X. M is the same thing as Y. And N is the same thing as where the right angle is Z. Okay, we should know this is a right angle because of the grid. And this is all right angle grid. If those 2 triangles are congruent, okay, without even necessarily paying attention to those triangles, but knowing that ln is 2 notches and zx is also 2 notches, I will say them. Let's go segments first because I did. That would be line ln, line segment ln, is congruent. Well, if I did ln here, it must be the same as xz. And if I do ln, yes, it's the same as xz. Okay, in that order if we rotated it. This is a rotation. Okay, if I did, say lm, that guy, lm should be the same thing as xy. And then mn should be the same thing as yz. And you can check that in your drawing. But to speed things up a tiny bit, I just use this to say them all. Okay? And you can do the angles. Angle L must be congruent to angle X. Angle M must be the same as angle Y. And angle N must be the same thing as angle Z. So if you get good about saying these numbers in the correct order, that's what's going to make this easier to write your congruency statements. If you write these LMN and you write this one as YZX, that's going to screw all these up unless you're really good at visualizing and looking at those guys in your drawings over there. So there's some difficulty there. You have to make sure you're either a visual learner or you can organize your letters in a fashion that you just need to know that to where you can name all of your congruencies. Either way can be a very effective way to get these done. So hopefully one or the other works best for you and you can narrow it down right away, pick the way that works best for you and use it so that it doesn't take you forever to work on these. Okay, those complete the ones. Oh, by the way, they both have to have the same hypotenuse, right? Because they both have the same leg, or right angle. If you notice that this is a 2 there and this is a 2 also here, hypotenuse leg are the same. So that would be one of the ones that you might look at and consider for why the hypotenuse leg theorem works. Okay, so I wanted to show you one of those. That's one of the reasons why I did number 3. Okay, that's as much as I wanted to talk to you today. All right, we'll see you. This was video 11, so when I start video 12, we'll see you then.